welcome you all. In my today's session, I am going to explain how to write C program to generate time delays. So today we will learn how to program timer. In last in my last session, I have explained you that timers has two application. One is time delay generator and other is as counter. In that session, I have discussed in detail that when I want to use timer as time delay generator, timer is driven through oscillator. Timer generates, timer is driven through oscillator. Oscillator generates continuous square pulses. These square pulses are counted by timers. So when we want to use timer for time delay generation, first of all is the source of frequency. The source of frequency is crystal oscillator. So that is the base. So what is the frequency? Frequency I have assumed as 11.0592 megahertz. So this is the frequency generated by oscillator. If you remember the schematic, this frequency is divided by 12, and that is the frequency on which my timer will run. So operating frequency of timer is oscillator frequency divided by 12. So this comes out to 921.6 kilohertz. So timer is running at a frequency of 921.6 kilohertz. As we are talking about time, so I convert this frequency into time. So time period of one clock pulse is 1 upon f. So 1 upon 921.6 kilohertz gives me 1.085 microseconds. So timer receives clock pulses after every 1.085 microseconds. Because the source is oscillator, it is generating continuous clock pulses at regular interval of time. So timer is receiving clock pulses after every 1.085 microseconds. Now we are generating a standard routine of 1 millisecond. So delay required is 1 millisecond. So for 1 millisecond, how many clock pulses are required? So formula is number of clocks required is equals to delay required upon time period of 1 clock pulse. So delay required is 1 millisecond. Time period of 1 clock pulse is 1.085 microseconds. This gives me 921.6. If I rounded it off to nearest level, it is 922 clock pulses. So if I count 922 clock pulses, time pass will be 1 milliseconds. Now 922 is 16-bit count because it is greater than 255. So it is a 16-bit count. So I will use my timer in mode 1, which is 16-bit mode of operation. And in that mode, I can count maximum 65,535 clock pulses. Remember, our timers are up timers. So to count 922 clock pulses, we have to return from maximum count. So what is the maximum count? 65,535 minus 922 plus 1 is done because when I count 922 clock pulses, I will reach to 65,535. One more clock is required to cause timer to overflow, which is an indication that delay is achieved. So this one is added. So we are subtracting 922 from 65,536 so that when I count 921 clock, I reach to maximum count and the 922 clock will cause the timer to overflow. So I will not add extra clock. I will not add extra time to my delay. That is why this one is added. So this gives me 64,614. If I convert this into hexadecimal, it gives me FC66. Now we know that timer has two count register TH and TL. If I am using timer 0, it will be TH0, TL0. So higher byte FC I load in TH, lower byte 66 I load in TL. So we have determined the count value, starting value of my timer. So timer starting value is determined. Now Tmod value. What will be the Tmod value? Timer mode register. We are using timer 0. We have already seen that Tmod register is an 8-bit register whose upper nibble is used for timer 1 and lower nibble is used for timer 0. So upper nibble we will assume as 000. So this will be 0 and lower nibble. First of all is gate bit. So gate we are not controlling timer through switch, external hardware. We are not controlling timer through hardware. So gate bit I keep it as 0. Then C oblique T bar. I am using my timer in time delay generation mode. So I keep C oblique T bar equals to 0 and I am using my timer in mode 1. So it is 0 1. So this gives me in hexadecimal, it gives me 0, 1H as the value. So this is how I have determined the Tmod value. Upper nibble is for timer 1, so I keep it as 0. Lower nibble, the 4 bits, gate bit I keep it as 0. C oblique T bar I keep it as 0. Mod bit, mode bit I keep it as 0, 1 because I am using timer in mode 1. So this is how I have determined the Tmod value. Now we start with our first C program. So we have already I have already explained that whenever we use SFRs, we have to define those SFRs. And those SFRs are already defined in a register 51.h file. So we include this file so that we don't need to explicitly define these SFRs. See here, tmod, it is 89H. So we are using tmod. You are not accessing this register using its address. Similarly, TL0, 8AH, TH0, 8CH. So I am using these SFRs in my program. So I have included this header file register 51.h in which all SFRs and all bits of SFRs are already defined so that I can directly access those SFRs and those bits. For example, TR0. TR0 is also defined in this header file. TR0, its address is 8CH. So I am not accessing the bits with address. I am accessing the bits with identifier TR0. TF0 is timer overflow register. So let us start writing the C program. So any C program will have minimum one function called as main function. So I write one main function. So I first configure my timer 0 in mode 1 and as time delay generator. Gate bit is 0, so no hardware control. Then I load TH0, I load TL0, then I start my timer. Then I start my timer. So timer is running. So whenever clock is coming, count is increased by 1. So how many clocks will be counted? 922 clocks will be counted. And after that timer will overflow. And when timer will overflow, TF flag will set. And when TF flag will set, so 1 equals to 0 will become false and this loop will be terminated. So when timer will overflow, this condition will become false and this loop will be terminated. And for 922 clock pulses, when TF0 flag is 0, this condition remains true. So when the condition remains true, again while loop will be executed. So this condition is executed repeatedly till the condition is true. So till timer is running, it does not overflow. This condition remains true and this condition is keep on executing. And when timer will overflow, this condition will become false and this while loop will be terminated. After that I stop timer, TR0 clear किया, stop timer, I clear TF overflow flag and then there is an infinite loop. So this is how I can generate time delay of 1 millisecond. So these are the set of instructions through which I can generate time delay of 1 millisecond. Let us execute this. Okay, so through from peripheral I open timer 0. So here is the mode application, whether you are using it as timer or as a counter. Then this is the tmod value, th value, tl value. This is tr bit. This is status, whether it is running or it is stop mode. So I press F11. I executed tmod. So you can see that your timer is selected in mode 1, which is 16-bit mode, and you are using it is as time delay generator. So time delay generator is selected and gate bit is also 0, so no hardware control. Then th and tl are loaded. Then timer is in stop mode. When I set this bit, timer will move into running mode. So now timer moves into running mode. Now when I press F11, when I execute this instruction once, two clocks are used by the microcontroller. Right now I am using single stepping mode. Right now I am using single stepping mode. So when I press F11, one statement of C is executed. So to execute this C statement, two clocks are required. So when I execute this C statement, oscillator gives two clock pulses. So timer will be increased by 2. So when I execute it, so 67, it was previously 67, now it becomes 69. I execute it once again. Now it becomes 6B. 69 था, it was 69, so 6A, 6B. I execute it again. So it becomes 6D, 6C, 6D. So whenever I press F11, whenever I execute this C statement once, two clocks are generated by oscillator and the count will be increased by 2. Now if I keep on pressing F11, so I have to count 922 clock pulses. So half of that will be 461. So 461 times I have to execute this instruction. So now I will move from single stepping to free running. So I put a breakpoint here. Now I will move from single stepping to free running mode. In free running, oscillator will keep on generating continuous square pulses and this instruction will be executed continuously. And when the timer will overflow, this condition will become false, program will proceed, and here is the breakpoint, and at the breakpoint your program will stop. Okay, so now I press F5 to move from single stepping to free running. So you can see that TF flag is set. So this condition becomes false. And here, when the condition becomes false, program reaches out to next statement, and here is the breakpoint, and at breakpoint my program stops. Now I clear TF0 flag, TR0 flag. Now here at the bottom we can find out the time period also. Okay, so we see the time period also in my, I execute this is again. Okay, so here whenever I execute this one statement, this time period is increased by 1. This is indicating the total time period. So I reset this timer to 0. Okay, so this I execute it once. So how much time is taken? 2.17 microseconds. So this instruction, this C statement again take 2 clock pulses. So time is increased by 2. Okay. So these all takes 2 clock pulses. So time is increased by 2. This will take 1 T state. So time is increased by 1. 1.0. It was 86. So it is 9 microsecond. 1.09 microseconds. Now I reset it to 0. Okay. Now I press F5. So how much is the time? 1.00 millisecond. So time delay is 1.00 millisecond. So for 1.0 millisecond, this condition was true. And after that, the condition becomes false. So total time delay is 1.00 millisecond. So that was all about how to write a program to generate time delay using timer. So I hope you understand and you like the video. So if you like, to please press the like button and share with your friends also. And don't forget to subscribe my channel so that when I load my next video, you will be intimated. Thank you. Thank you a lot.